if you're given this function 1 over x equals fx, you are asked to figure out the transformed function gx equals fx plus 6 minus 7. You should follow the following method to get the transformed function's graph. We have known this is the base function, but in your mind you should have this idea that you say x cannot be equal to 0 because x is in the position of the denominator, so x cannot be equal to 0, otherwise this function will be undefined. Additionally, because the numerator is 1, so this quotient will not be equal to 0 forever. So fx cannot be equal to 0 forever, okay? Let us say on the graph, we have known for this function, it should be 2 branches. This is the right branch, this is the left branch, and we can assume this point and this point, in fact, they are the key points for this function. X cannot be equal to 0, that is to say, y-axis, x equals 0, meaning y-axis, and y equals 0, meaning x-axis should be the asymptotes of this function. That is to say, the branches should approach the y-axis and x-axis more and more closely, but never touches. Okay, now let's analyze this function. First, this function a is 1, the coefficient of the bracket k is also 1, so we don't need to do any stretches and compressions in the horizontal direction and in the vertical direction. We just need to focus on translations according to this parameter and this parameter. Okay, first, this one, fx plus 6. That is to say, this denominator should be replaced with this one. Okay, 1 over x plus 6. Here, you need to know, in the position of denominator, x plus 6 cannot be equal to 0 forever, so x cannot be equal to negative 6 forever, and this coefficient will not be equal to 0 forever, so we can figure out x equals negative 6 and y equals 0 should be the corresponding asymptotes, but x equals negative 6 should be the vertical asymptote, y equals 0 should be the horizontal asymptote. Okay, now we can figure out the corresponding two asymptotes here. This should be x equals negative 6 and y equals 0, still this x-axis. Okay, now on the base function, this point, it should be moved to the left side by 6 units, because here d should be equals negative 6. That is to say, if you want to keep the y coordinate unchanged, you must move this x coordinate, that is to say x0, to the left side by 6 units. Okay, so this point, its image should be here. That is to say, negative 5 and 1. And this point, its image point should be minus 1, minus 6. This is the new x coordinate. It should be negative 7, but the y coordinate, okay, here it should be negative 1. Negative 1, okay? The new image point should be here, negative 7, comma, negative 1, okay? It should be here. So this point is the image point of this point. This point should be the image point of this point, okay? Now, we can figure out the corresponding branches like this, okay? you can do the same translations according to this method for every point on the base function. For this branch, you also do the same transformation or the same translations for every point on this left branch. Then you connect the corresponding image points. You can figure out the transformed graph of this function. Okay, we can get this branch. Okay, it should be f(x plus 6), f(x plus 6). Okay, if you can figure out this graph, you are close to the final transformed functions graph. Okay, on the basis of this functions graph, you just need to translate the graph in vertical direction by 7 units. But here, -7 meaning we need to translate this functions graph downwards. Okay, so this branch and this branch should be moved downwards by 7 units. Okay, now we have known 1 over x plus 6 cannot be equal to 0. So we can figure out this is the horizontal asymptote. But now we need to -7 for both sides. So this gx, because this is the gx expression, so we use gx. We can figure out gx cannot be equal to -7. So the new horizontal asymptote should be this line, but the new vertical asymptote still this one. Okay, so we just need to move this one. Okay, we need to locate this -7. So this is y equals -7. Now you can easily get the image point for this point. It should be here. Okay, that you say x coordinates should be kept unchanged, but y coordinate should be moved downwards by 7 units. Here it is +1, so 1 minus 7, it should be -6. Okay, this point and this point, originally it is -6 minus 1, so -6 should be -6, but -7, -1, -1 should be -8. Okay, so it should be here, -6, comma, -7. Here it should be -5, -6. Okay, then we can get the corresponding branch here. The right one, the right branches should be the gx. Okay, then we can use this method to mark the transformed final function gx. Okay, from the previous analysis, we can figure out the exact expression gx should be 1 over x plus 6 minus 7. But you need to add the restrictions. That is, x cannot be equal to 6, and gx cannot be equal to -7. But according But of course, we just need to add the restrictions for the domain, so you don't need to add this restriction for the transform function. Okay, so this is the exact expression, and this is the corresponding graph for the transformed function. That's it.